Hey everyone, today got a little treat for you. We're going to do a how-to video on how to do V Carve on a 3D surface using Fusion 360, and we'll get some pretty good real-world results, especially on the CNC machine. But first, we got to figure out why Scarlet is so sad. So yesterday, we had a severe hailstorm come through, and it dropped baseball-sized hail, and my Durango got nailed. And but again, like everybody's safe. It's great to have good auto insurance, but this delayed my website going live and a YouTube giveaway this weekend. So next weekend we're gonna go ahead and do that. But the dogs are pretty excited. I'm gonna knock this video out, and we'll get some learning today. So I'm going to put all the links in the description on the websites for Etsy, where I got the 3D file. Again, this was not my original design as far as the 3D contour, but I added things that I wanted in Fusion 360. And if you ever worked with Fusion 360, it is extremely painful. But McKinney's Woodworking, he has some really good designs on here, and the way he did the 3D effect was super awesome, and that's why I chose this file. And it gives me a little bit of flexibility too, in case I want to do a inlay for the stars instead of like a V carve. So the model was really good. I didn't have any issues importing it in 360, but we're going to walk through all those steps on exactly how I did this. So if you ever downloaded anything off Etsy, most of these are digital files that get emailed directly to you after you buy them. Once you get the email, you just click on the zip file, extract the files that came with it. And this file, he ended up having a SVG, the 3D model, and some pictures. So again, it's pretty well put together. He does some phenomenal work, and again, there's no affiliation between me or him. I'm just kind of showcasing how I use his product to meet my needs. And this SVG file is what I use for the star pattern, and we're going to walk through all that. Another thing that I wanted to show is the dimensions of the American flag, and there is a calculator online. I'll leave that link in the description also. This gives you the by regulation dimensions of that American flag. And what I did is I kind of rounded up because the flag was so small. I didn't have to worry about, exact dimensions, but I wanted this 12 by 6.5. And this calculated the width of each stripe that I needed to cut, and then some other dimensions for the star width and all that. So if you're doing a larger project, this is a great tool to get those dimensions, and they're pretty spot on, and that calculator definitely helps. So I took that, and I'm going to use that for my initial design when I open up Fusion 360. Now, Fusion 360 is not for everyone. It is a complicated drafting software. It does a lot of great things, but for a novice like me, I have to work through how to make it work for me. There's other 3D software that you can use. Carbide 3D has software, Aspire, V Carve Pro, like they're all great software. I just use Fusion 360 for it because it's a little bit easier for me. So I went ahead and I just created a sketch. It's going to be 12 by 6.5. I used the rectangle tool, and I went 12 by 6.5. And then what I'm going to do is I'm going to import the 3D model that I just downloaded off Etsy, just to make sure my scaling is correct. So from the import, I'm going to go to mesh, and I'm going to find that original file that I just downloaded, import that in, and it's going to be quite large. It's not going to be exactly what I want it to be. So I'm going to have to go through and start scaling this to size to meet my needs. So I'm going to go ahead and modify this, and then I'm going to go ahead and scale it. So from the modified ribbon, I'm going to select scale. And this tool is kind of funky. You have to go fractional to get it to your right size, but you can see my original rectangle on the bottom left-hand corner. And I'm just going to fit it within that box, but I'm going to make sure that it's overlapped. That way the contour of that 3D surface is within that or outside that 12 by 6.5 box that I want. And this takes a little bit of time to play around with. I'm going to move it over to the actual rectangle, and then I'm just going to kind of slight adjustments to the overall scale of it. Now, this doesn't have to be perfect because I'm only looking for the actual contour of the 3D surface. What I don't want is it's inside the box where it's not going to actually capture that surface for me. And what we're going to do is we're going to split this box in half, and we'll walk through that together. So you can see I overlapped it, and so it's outside that original box that the original sketch that I created. And so what I'm going to do now is I'm going to extrude and create a new surface below that. But first I got to correct this mesh, and I got to convert this into a solid. Now, Fusion360 is really funky, and it's when it deals with 3D surfaces, it doesn't deal with it very well, and it's very labor intensive on your computer. So what I'm doing now is I'm just converting this into a solid, and you can see all those vectors inside that. I think there was like 15,000 of them, and Fusion is trying to calculate every single movement that I'm doing or any kind of edit. And again, it's very labor intensive on your computer. So right now I just converted it to a solid. And what I'm going to do now is I'm going to create a new body. And that's going to be the actual dimension of the thickness of my material that I'm going to use for the flag. And I went ahead and used 3/4 of an inch. And what I'm going to do now is I'm going to move that new body into that 3D surface, because I'm going to use that as I'm going to slice it in half. Basically, I'm going to create 2 more bodies. And what I want to make sure is that the body that I want sliced is within that 3D surface, so it doesn't extrude out. Now there's a couple of different ways you could do this. You could use the combine tool and cut it. I went ahead and used the slicing tool, and I sliced the original body with the mesh body that I had, and that creates 2 new bodies. And I went ahead and just hid those, and only worked with my base material that I know what the current thickness is. So that is the contour of what I'm going to go ahead and cut out on my CNC machine. And that is exactly 12 by 6.5. What I'm also going to do is I'm going to check the thickness of the lowest point, because I'm going to inset this into a base material. And within the plaque that I had, it ended up being oak plywood. And the pocket that I created for that was 1/8 of an inch. So I had 1/8 of an inch worth of material from that top of the flag. So that way the actual curve didn't actually go in and into that pocket to where you could see the edges. So right now I'm just going to verify that meets that requirement. I think it was above 1/4 of an inch at its lowest point. So now I have a good base to start with a good 3D contour that I know I can work with. I'm going to go ahead and I'm going to start doing the star layout. And again, there's multiple different ways you can do this. This is one way, and it's probably the wrong way, because I could have extruded a different plane and then, started my image off of that. But what I ended up doing is just selecting that corner on that face, and I just drew a line above the surface. And then what I'm going to do is I'm going to create just a new body, and then draw a sketch on that body for the actual star layout. And then I'm going to extrude those downwards and cut into the base material for all the stars. So this is one way. It's probably not the correct way, but it's the fastest way that I know how currently with Fusion. And again, there's multiple different ways you can do this. So I went ahead and just extruded. These dimensions really didn't matter. The only thing I wanted to make sure is I had the height to where it didn't touch the base material that I wanted to cut into. So from here, I'm going to create a new sketch on top of that face of that new body that I know the distance of. And then I'm going to import that SVG that came with the original download, and I'm going to use that as a template for the rest of the stars. So I'm drawing a rectangle that's 5 by 3.5. That was the original calculation from the tool that I used to calculate those distances. And now I'm just going to import that SVG file in and then start manipulating that file. Now you'll have to manipulate the SVG. You'll have to rescale it. I was not exact on the placement of this. If it looked good to the eye, that it was kind of centered, it worked for me. Again, this flag is extremely small, and you're not really going to notice whether it's a 1/16 of an inch off or a 32nd of an inch. The application didn't really matter. But I just wanted to make sure it was kind of centered. It looked good. The placement was good. And then I hit OK to actually import this SVG in. And then the lines of the flag actually came through too. So I went ahead and just deleted all of those out. And I only wanted the stars showing. So there was just a little bit of cleanup. All right, so from here, we're going to extrude and cut these into the base material. Now, the distance doesn't really matter as long as the entire star cuts into your base material. And you're going to notice that the pockets that I'm going to create here, some were really deep and some weren't. And it was all depending on the 3D surface on where it was located for each star. And this is not going to matter once we go into the machining. And I'm going to use a really cool tool that will just follow the contour with your 60-degree V-bit that I'm going to use. So again, I'm just making sure that the entirety of the star is cut into the actual surface. Sometimes if you don't cut all the way in, some of the points on the star itself won't actually cut into it. So just go all the way down, don't go all the way through. So that's the profile for the stars that are cut into it. Again, this was the fastest way that I could do it within Fusion. I was on a kind of a time crunch on this particular project when I originally did the original flag for one of my customers. I had a day to do this, and I didn't want to design an entire 3D flag and try to fight Fusion on doing this. There's other applications that more than likely can do it faster. All right, so here's another important step. I'm going to go ahead and I'm going to suppress that extrude because I don't want the when I do the contour of the flag with one of my taper end mills, I don't want that to cut into the actual stars. My V Carve is going to do that for me. So we're going to go ahead and move into the manufacturer portion of this. And I'm going to import a tool library from Amana. They have a great tool database. Every single tool that they have is basically inside this, and Fusion will recognize all the parameters. And most companies that produce bits, they have a tool library, and you can import these. And a lot of the other CNC motion softwares will recognize it too. And but again, it's really nice. It takes all the guesswork out for feed rates and RPMs and tool diameters. So you can import all of this right into Fusion, and it takes all that guesswork out. So we're going to move in and we're going to create a new setup within Fusion. And I made sure that I took all the offsets off when we did the initial setup. So I know that it's 100% 12 by 6.5. I know my thickness. I went ahead and I ensured that my XYZ was centered within the material and that they were pointed in the right direction. And these are all default right when you enter into the manufacturer portion of the setup. Now from here, I'm going to go ahead and do a 3D pocket clearing. And I'm going to use a spiral plunge 1/4 inch end mill. These things are super nice. Again, I'm not using any guesswork. I'm using the tool library with all the preset diameters. What's really nice is Amana tool actually labels all of your bits on the actual bit, so you can actually just reference it really quickly. I'm using all presets here. And what I noticed, I went ahead and changed this from 180 to 90, and default was 180. My machine cannot handle that. So as I move to the other options here within the tool, I'm going to go ahead and put a bounding machine area, and I'm going to select the bottom of that half, and then also verify all my geometry. My clearance, retract, top, bottom height, all of that stuff matters. It's already predetermined within the software. I just like to verify it. From here, the only thing I really changed was I changed it to conventional as far as the direction of the bit cutter. And then also the maximum step down clearance. And I changed that to a 1/8 of an inch. That way, that's the max distance it will plunge down. And then I changed it from helix to plunge. And then what's really nice is I can see all my tool paths within Fusion, and then I can also simulate it. And I'm going to run a quick simulation, double check the amount of time that it's going to take to cut out this portion, this first tool. And everything looks really good. And there's no red marks of clearance issues or anything like that, or if the tool is going to run into anything. And then it left enough space. So when I do my next tool, it's going to leave a really nice edge, and I'm not cutting into any of that. So this one's for the next tool, I'm going to use a tapered angle ball tip, and I'm going to use the parallel tool. And that's within the 3D, the option there. Once I get the tool selected, these parameters were all correct. I really didn't have to do anything other than change my my step over, and I increased it pretty good. I went to 0.03. This one is, again, it's 1/8 of an inch, and the tip, it leaves a little bit of material. And when we go through the simulation, you'll kind of see it. I kind of like it, but again, so I did the same as before. I select the boundary within the material, and it will keep that tool within that boundary. I went ahead and made sure that multiple depth wasn't already taken out because I already removed the majority of the material from my previous pass. And then there was no changes here. This is about a 30-minute cut for this. Now, if you decrease your step over, it will increase your runtime significantly. I like to keep it a little bit larger just because I have, it takes time away from my CNC machine. And then really the only thing it does is I have to do a little bit more sanding. But with these flags, I'm kind of thinking about leaving the step over larger and seeing those lines because it kind of gives it a really cool texture, almost like cloth. And you can actually see like where the tip of that ball nose, it's not removing all the material for each pass, and it's leaving a little bit of line texture there. And in the end result, it actually looked pretty cool. So I'm going to go ahead and I'm going to post these processes, and I'm on a different machine than what I'm at in the garage. And so the software I use to do the post processing on this is not on this computer. So those options aren't in here. But Fusion360 does a really good job of just, exporting all of this, generating the G code, and Carbide 3D motion software interprets it perfect. So I don't see a whole lot of deviation from what's being simulated to what's happening on the CNC machine. So now what I'm going to do is I'm going to go ahead and use the pencil tool, and we're going to use a V Carve bit for this. And the pencil tool is really cool. But before I do this, I had to unsuppress that extrude and then go back into manufacturing to make sure that those holes were available to choose. And with the pencil tool, again, the depth of that pocket does not matter. It's going to stop within the your selection that you're going to do. So this is a 60-degree V-bit. And the reason why I chose this, I don't want the depth to be too big, and it will stop within those lines of my selection that I'm going to tell it to be bound in. Again, it's all preset. There's no guesswork. I didn't change any of the settings for ramp speed or anything like that. So within geometry, I'm going to use selection, and then I'm going to modify that selection to select the pocket of that model. And then what I'm going to do is I'm going to go in and I'm going to select all the pockets within those stars. And I sped the video up just so we can get through this a little bit faster. But once you have all the stars selected, those pockets, what it's going to do is it's going to take the V-bit and it's going to constrain it within those. And it will only cut the material that's surrounded by that 3D contour. For in-pass and my ramp, I didn't change any of those settings. I left everything default. The biggest thing though within geometry, and you're going to see it just right now, is I'm gonna turn on resting machine. That's basically telling Fusion that it's going to ignore all the material from the other cuts. It's gonna take those into account, and it won't cut those. It's defaulted with an offset. I just put that to 0. Again, no changes. Everything is basically correct. These are just all default values from the original tool itself. All right, now you can see that it ignored the bottom of that pocket and it was constrained within that selection, and it only cut what was left from the previous toolpath. And we'll run a quick simulation here. I'm going to turn off the edges so you can actually kind of see this. And there you go. That's how you V carve into a 3D surface. And it seems really easy. It took me almost a half of a day to try to figure that out, because there's not a whole lot of tutorials on Fusion 360 on YouTube right now. And when I was going through the comments from the original video for the flag, a lot of people asked me. I have a lot of messages in my inbox just about this. And it was only right for me to do a quick video, kind of explaining how to do it. And but again, so I kind of hit this on my other videos. 3D software is great, the simulations are great, but things don't translate that well in the real world, and you kind of get mixed results when you put this into a machine with actual material. Things move. The software with your motion kind of interprets something a little bit different. Sometimes that happens. So before you even use your really nice wood like red heart and curly maple, I highly suggest just doing test cuts. Throw in a piece of pine and let it go and make sure that you get the result that you want. I definitely did that when I made the first flag, because I didn't want to waste that really nice material. So moving into the real world now, you got to make sure that all your measurements are correct. I went ahead and I made sure that this flag was exactly 12 by 6.5, and I had a really good center point. Most importantly is making sure that when you put it into the machine, it actually doesn't move. And so I use double-sided tape. I have really good results with this, but man, sometimes that can be like cement on that board, and like it's hard to pull up, and you can damage the material after it's done being cut. But making sure that you got a good base, everything is solid, you have a good center point, your zero is good. And then again, when you start cutting this, you're going to lose your Z, your up and down zero. When you're changing your bits. Fortunately, Shapico Pro has a bit setter, so my original zero height is automatically calculated when I do my tool change, and it will come over and it will measure what that distance is automatically, and then it will go right into the second cut with my new bit. And again, I like to clear out the material before I use my tapered end mill, and it increases the life of my bit. These things are pretty expensive, and I'm trying to get the most life out of them as I can. But I'll probably do another plug for Carbide 3D. They make a heck of a machine. And again, I am not sponsored. This is my personal opinion. I'm sponsored by no one right now. And I love the machine. It does exactly what I want it to do. But it takes time, especially going through 3D software for the first time. If you're just getting the machine and trying to navigate that realm, there's some time that you have to invest. And fortunately, everything really does work out pretty well with Fusion 360. The V Carve is moving exactly with that 3D contour that I put in from the previous tool path, and I had some really great results. And hopefully this kind of helps you guys. Fusion 360 is a free software. You can also do it on a subscription. I have the subscription because I use Fusion360 every single day. I can there's a little bit more that comes with what the actual subscription gives you. So, but the free version, I used that for a year and a half, and I loved it. And it did exactly what I wanted it to do. So you don't necessarily have to have the subscription. But again, it did exactly what I wanted it to do. I had really great results. The customer loved it, and that's what really matters at the end of the day. But again, this is just one way of doing this. And hopefully you guys experiment with it. Maybe this video helped, maybe it didn't. But definitely stay tuned next week. After I go through all this insurance stuff with my car, I'm going to put out the free YouTube giveaway for that cribbage board. That cribbage board is amazing. I love cribbage boards, and I love designing cribbage boards. And it's going to be a pretty unique thing that's coming up. All right, that's it. Thanks for watching. Hopefully you guys made it to the end. If you did make it to the end, leave me a comment. Let me know what you guys thought. And yeah, more to come. And I really appreciate it, guys. Thanks.